looking at speed. This is for regular physics students. So if you're pre-AP, this video isn't for you. So we'll be looking at speed. So we started with this worksheet. Speed's how fast something is moving, right here. And so specifically, it's the change in distance over the change in time. And if we have a lot of noises coming in, we've probably got a lot of announcements before school starts. So what you do is you take a problem like a plane flies 200 meters in 5 seconds. Best thing to do is underline, anytime there's a number, underline the number and then the word that follows. This is the unit. Okay, so they're going to be telling you what the number stands for. Meters is a measure of distance, so put a D over that. And then seconds is a measure of time, so put a T over that. So the 200 is distance and the 5 is seconds. And you write it down over here, distance is 200, time is 5. Put your formula, and then you substitute in and you show your work 200 over 5, and that gives you 40. And then you put your units in there. And again, since it's 200 meters over 5 seconds, then you just keep that and you bring it down here. You leave those meters over seconds. You can't do anything with them. You just write them down. Whatever goes with the number stays up there and then brings it down with it. Another concept is this. You'll see this sometimes. This is about the only way we can show you a process of something. And what happens is the spaces represent the distance. Each dot represents a certain amount of time. So let's say that each dot represents 1 second. So if you get your ruler out, you get your distance here, and you can say, oh, each dot, since it's uniform, which means it's the same amount of space in each one, that means this is a constant speed, and it's fairly, let's say it's slow. This down here also representing 1 second for the dots. They're much closer together. The distance is much smaller. So if you cover so am I getting that right? No. This is, and that's how this thing goes. This is why it's always backwards. It's always fun. This is fast because you cover more distance between each dot. This is less distance. So this is slower. So what you do is you think about the distance over the time. It's the same time. Whenever you look at these two, it's the same time. This one up here covers more distance. So the one downstairs, down here, is covering less distance. All right. And it was steady. Now, so let's look at this. This is on the back of your paper. Here's your 0 mark. And they say, how long did it take to go 15 meters? So here's your 15 meters mark. If each dot is 1 second, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it takes 10 seconds. So the speed is, he went 15 meters. So that is 15 over 10. And we get 1.5. And that's meters over seconds. So we're going to write meters over seconds over here. And don't worry about the bottom question. Top question, is it a constant speed? And the answer is yes. The answer is yes, because the dots are evenly spaced. That means it takes the same amount of time to cover the same distance each time you look at the distance between the dots. All right, let's look at some of the math you should have done. All right, a bike moves 50 meters in 10 seconds. So the distance is 50 meters. The time is 10 seconds. Formula is V or S over D over T. So it's 50 meters over 10, and that gives you 5. And you shouldn't really write these in your notes, but I just want to see where it comes from. It's 50 meters over 10 seconds, so it's going to be meters per second. The second one says a car travels 200 miles in 4 hours. So that's 200 for the distance, for hours. We use MI to represent miles. Formula is the same. V equals D over T. So it's 200 over 4. And that's going to give you 50. And the units on this one were 200 miles over 4 hours. So that's going to be miles per hour, MI over HR. So that's how you do the math. And today you'll be working math problems. So it's the same type of stuff. If they ask you how far it traveled, they're looking for D. 10 seconds is time. 60 meters per second is your speed. So your speed equals 60. And your time is 10. You're looking for D. It's still that V equals D over T. But when you rearrange the formula, what you're going to end up with is D equals VT. Everyone write that down so you'll have it somewhere. So all you have to do is 60 times 10. And it's 600. And distance uses, since this is meters per second, distance uses meters. Okay. So this one's a little bit bizarre. What it's trying to say is here's Meyerville. It's at the 10 mark. And here's Sprytown. It's at the 70 mark. So the distance you're going to travel is 60. So your distance is 60. And your time is 3 hours. So V equals D over T. 60 over 3. That's 20. And it's miles per hour. All right, good luck.